What is nuclear energy and how does it work? Since the beginning of the Industrial Revolution, the demand for energy has increased dramatically year after year. Today, the majority of this demand is met with the combustion of fossil fuels. With the recent disaster at Fukushima, as well as the ever-present effects of the events at Chernobyl and 3 Mile Island, nuclear power has lost some of the enthusiasm that once surrounded it. Because of the rising costs and harmful effects on the environment caused by fossil fuels, people are looking for ways to replace our dependence upon them. While renewables such as hydroelectric, solar, and wind energy have proven to be worthy replacements, they are still a ways off from meeting our needs. Nuclear, on the other hand, has all of the technology required to be used on a large scale. In the US, nuclear accounts for 21% of the electricity produced, whereas coal contributes 41%, natural gas 24%, renewables 12%, and petroleum only 1%. Despite the current level of adoption, there is still a great deal of misconception and fear surrounding nuclear energy. Now, let's see how most nuclear power plants actually work. First, you have the fuel, usually uranium, which must be mined, enriched, and then formed into pellets that are placed in rods within the reactor. The atoms of uranium undergo a controlled chain reaction which emits heat. Pressurized water around the reactor vessel is heated and circulated through pipes in a steam generator, which produces water vapor that spins a turbine attached to a generator. After leaving the turbine, the steam is condensed so that the cycle can continue. The benefits of using nuclear fuels are numerous. The lack of carbon emissions, the ability to create huge amounts of energy, and the reliability of power production are all extremely important. As there are no fossil fuels used in the consumption of uranium, direct carbon emissions are non-existent and indirect emissions are limited to the construction of the facility and obtainment of fuel. Unlike many renewable methods, nuclear plants do not depend on the conditions around them to function, which would make them perfect for the constant baseload of the electrical system. The main concerns surrounding nuclear energy are safety, waste management, and total expense. Contrary to popular belief, nuclear is among the safest sources of energy that is currently in use. Despite the seemingly huge impact reported by the media, there have been no deaths as a direct result of the meltdowns at either Fukushima or 3 Mile Island. Even in the case of Chernobyl, the total number of expected deaths is quite low. In comparison, deaths due to the use of coal are over 10,000 per year in the US alone. However, deaths are not the only impact which an accident can have. They can force people out of their homes and change the land around them for a very long time. For the treatment of waste, there are 2 main options that are currently employed: containment and reprocessing. Containment is the placement of exhaust fuel in safe containers where it will remain for a very long time. The second, and more expensive method, reprocessing, treats the waste so that it can be used within a reactor again. Nonetheless, reprocessing is not currently practiced in the US due to a lack of facilities necessary. Furthermore, costs come mainly from the building and regulation of plants. These high initial costs can be mitigated by focusing on uprating current plants instead of building many new ones. Finally, technologies are being developed which can further decrease these disadvantages. So then, how can nuclear play into our energy future? Combined with renewable sources, nuclear allows us to enjoy our energy needs without the impact on our environment that is coupled with fossil fuels.